Hello and welcome to the next topic in this first week. We're now looking at primitive operators. These are things we can actually do with our variables, different ways to mix and match and math them. This is quite a short set of information where I will do a little bit of coding and it will be probably pretty quick. Okay. So today's learning goals, there's just the one here, performing basic operations on variables. Awesome. So we saw all of our different types of variables, pardon me, like ints and floats and doubles and chars and strings. And we have different types of operators that we can do on these. There's the plus sign, addition, minus, division, like minus, slash, and star. So subtraction, division, multiplication. There's a percent sign, which is modulo, and then there's plus plus and minus minus, meaning increment or decrement by 1. I've put in brackets beside each the types of data, like the data types that you can use for each of these operations. For example, the plus sign, so addition, we've seen it. We can do it with strings. We can squish strings together. We can also do it on numbers, so like ints and floats and doubles and longs, because it will literally just do math. Minus, like subtraction, division, multiplication, these are all things that can only be done on like numbers, so decimal numbers and whole numbers. Modulo, this can be done on integers and technically on floating point values, but floating point values, like so decimal values, start to get really weird with it, so I just don't recommend it, which is why I crossed it out. And then incrementing and decrementing, so these sort of fancier operators here, these can be done on numbers, so on both decimal and whole numbers. So let's pull up some like a coding file so we can get nice and ready to practice each of these. I'll go here, public class primitive, operators. Save it as primitive operators.java, and I am ready to go. Now I'm going to just add myself in a little line here that tells me that my program ran, so that I know that as I'm adding stuff, I'll know that it worked properly and made it all the way to the end when I see program ran come up in my terminal console here. So first I'm going to go and navigate into the right folder. Yep, I'm in it, and I can say javac star.java, and I can list it, and I can see that my primitive operator.class file did indeed get created right there. So when I run it, I get program ran. So I know everything is working now. Fantastic. Let's continue looking at things that we can do. So the first thing that we're going to look at is that plus sign, right? So it's a binary operator, which means it needs two operands. It needs to actually take two different things and plus them together. It can accept two of any of the following. So it can be a char, byte, short, double, int, longs, or strings. Some combinations work and some don't. So for example, you can take a char and add it to another char, or you can add a char to an int, or you can add like strings and strings. But you can't easily add, let's see, a long and a char. Like that might not work. So there are some combinations that work really well and some things that don't work really well. And the easiest way to figure it out is to try it. Now I can tell you that a string plus anything will work, and it just squishes them together. It'll turn the whole line into a string. So hello plus 1 gives us hello 1. Hello plus false will give us hello false. Let's go ahead and just take a quick look at this, because one of the easiest ways for us to know if these things are true, if they work, is by trying it. Now, I'm not going to do it in, I guess I'll do it in literals. So we'll say system.out.println, and I can say hello plus 1, just like it showed us in the practice in the notes. Running it, we can see hello 1, and if I try hello false, just as it suggests, hello false. So it's exactly what it says. It just kind of shoves them together. If you wanted a space between them, you'd have to actually like hard code like spacebar, like hit the spacebar. Okay. Any of the above, chars, bytes, shorts, doubles, ints, longs, can be combined with pretty much any of the above. Again, not including Boolean on either side of that operand. So you can't do like false plus 1, I don't think. Should we try? Let's just try. Let's do false plus 1 and see if we get an error. We better get an error. We're going to get an error. I think we're going to get an error. Phew, we did. Bad operand types for the binary operator plus. Well, we just learned what all these words are. Bad operand types. That means that there are two operands, one on each side of the operator, the plus sign, and one of them is bad. The first type is an int. The second type is a Boolean. One of them is bad. We happen to know that false is going to be the one that's bad in this case. So now if we try to compile this instead, it will work, and it will just add the numbers together. What about two Booleans? I don't think that will work either, but let's just try it. I'm pretty sure Booleans can only be combined with strings. Yeah, you can't do it. Haha. Okay, we'll learn more about Boolean operands or operators later, but that's pretty cool that we can test that and see what happens. Okay. Cool. So we talked about like what was bigger or smaller before, but I hadn't actually shown it to you in like a drawing. So here we can see it in a drawing. Doubles are bigger than floats, are bigger than longs, are bigger than ints, are bigger than shorts, are bigger than bytes. So bytes are the smallest and doubles are the biggest, which means when it comes to casting and combining things together, when we use that binary operator, it's important that we understand what the resulting type is going to be. If you combine a double plus a double, you will get another double. If you combine a double plus an int, what will we get? Well, let's ask ourselves, pardon me, if we combine a string plus an int, we got a string. If we combine a double and an int, what are we going to get? Well, doubles are bigger than ints, so we should get a double, which means 1.0 plus 1 should give us 2.0. Let's give it a try. There we go. So it follows that order where strings are the biggest, which means if a string is present, it automatically turns the whole thing into a string. Whole thing into a string. Whereas this one here is turning it into a double. So for example, if we have an int x1 and a double y 1.0, we cannot, this will not work, z x plus y. Nope, z is too small. Z right now is an int. That is not going to work. Not without a cast. See? Error, incompatible types. Possible lossy conversion from double to int. So either you explicitly say, no, I know what I'm doing. I want to convert this into an int, and then it works. Or we get rid of that cast, and we just store it in a double. And that also will work. Now z is not too small. We can get rid of that comment. Okay. Let's flip back. Cool. So here's another quick pause and practice. Which of the following outputs will be run? What will the following outputs be when run inside a print statement? And if you think it will just be an error, you can say error. So the idea here is that you first make a guess, and then you have to try it to see if you're wrong or right. And if you're wrong, but you're not really sure why you're wrong, go into ChatGPT and ask. Take the question and say, why does z plus 1 equal whatever instead of whatever you guessed, right? So a plus b in that formula that I gave you is going to be whatever the question was, y is the real answer, and z would be your guess. So go type it in and figure out why the different answers are what they are. Once you've done that, come on back and let's continue with primitive operators. Okay, I'm assuming you're now coming back to talk about more primitive operators. Here we have minus, divide, and multiply, and these are done on numbers. And it works exactly like the addition, where doubles times ints will give you a double. Double divided by double will give you a double. Double divided by int will give you a double. We're always going to end up with a bigger value, and we can do this math exactly as we would expect to do it. Now, modulo, you should have learned it previously. It also works exactly as you'd expect it to be working. I just am going to strongly recommend you just use it on integers rather than on floating point values. More specifically, what I mean is like when you have a plus b modulo c, that c is an integer. It can be a decimal value, but I would strongly recommend that it is not. A and b can be whatever. C should be integer. It gets really wonky otherwise. So these work just as you'd expect, but like I'm telling you, you can get weird rounding errors when you're dealing with decimal values, right? Floats and doubles have decimal values, and different computers compute these differently. You can get some weird rounding errors to a certain point. Like at a certain point, it doesn't really matter, and for our purposes, it doesn't really matter. But it's just important to remember that if you're getting a slightly different answer when you're doing some practice with your friends, and their answer looks slightly different, like there's an off by 1 or off by 0.1, there's a good chance it's a rounding error. This seems to be particularly obvious when you do modulus, which is why I'm telling you don't do it with modulus. Don't do decimals with modulus. Cool. There is no exponent or power operator like we saw in Python. In Python, you could have like star star, but there are special methods that we can use to do exponents and powers, and we will see that in just a couple of sections here. Whoops. Wrong way. Okay. The last main two operators that I want us to look at here for both decimals and whole numbers are the increment and decrement operators. So plus plus and minus minus basically increment by 1 or decrement by 1. Let's just take a super quick look at what that looks like in code. So if we have a int a equals 1 and a plus plus, this is the same as saying a plus 1 or a plus equals 1, and basically now a is 2. So it's just a shorthand form of incrementing your values up by 1, which we'll see uses for. For example, if you're just trying to like have a method that increases somebody's age when they have a birthday, that would only go up by 1. Typically, our ages don't go up by more than 1 at a time. Or I don't know, that's a really good example. So let's just hold on to that example. Or if we're looping through something and we're looking at each value counting from 1 to 10, we have to go up by 1 each time. So we can do that going upwards, or we can do it going downwards, and this would be the same as saying a minus 1 or a minus equals 1. We want to print these out, and just print a there, print a there, print a there. Let's just take a quick look at what we get. We can see the first time we print a, it's a 1, then a plus plus. So when we print it next, we get a 2, and then a minus minus. When we print it next, we get a 1. Cool. Okay, so I just wrote that in words, but just to show a plus plus and b minus minus, those are equivalent to a plus equals 1 or a equals a plus 1. It's just a shorthand, and the b minus minus would be equivalent to like a minus equals 1 or b equals b minus 1. But this also means we can do some other really cool things like plus equals 5, where we can like count by 5s, or plus equals 2, and we can count by 2s. You can also say times equals 100, and that will multiply it by 100. Or divide equal to, which will divide it by 2. So if you know you want to divide a value by 2, you can say c equals c divided by 2, or just c divided by equals 2. It's just worth noting that you can't do things like c equals 100, c is divided by equal to 2, right? That will give us c being 50. Oops. This would mean nothing. Is that the divide symbol? Is that the right way? Yeah. Right? We can see it turns it into a comment. Like that doesn't mean anything. We can't do this. Like that's not a thing. So especially because if you like did this and if it really did mean anything, it would mean what? Like multiplied by 1, it would still just be 1. If you did this, divide by 1, it would still just be it would still just be C, right? It's like those don't really mean anything. So for those two, like divide and multiply, you'd have to do it in like this, which is the same as saying C is equal to divided by 5. It's just a shorthand for changing a value and reassigning it back to itself. It's just a neat, nifty little shorthand for that. That's all. So here C would be now like 10. We can print it just to make sure I'm not wrong. Oh, I forgot to actually make it into a variable. You got to declare it before you use it. There we go. 10.0. Awesome, because it is a double. Okay, that's all I have for primitive operators. Make sure you give them a good practice and feel comfortable using them, especially some of these shorthands, before you move on to the next one.